Welcome back to the DevOps Week by Simply Learn. As announced, we are here with Docker and Kubernetes. Docker is an important open source platform for building, deploying, and managing containerized applications. Docker simplifies the delivery of distributed applications and have become increasingly popular. Similarly, Kubernetes provides an easier way to scale up your application compared to virtual machines. It keeps code operational and speeds up the delivery process. Kubernetes API allows automating a lot of resource management and provisioning tests and much more. We will begin this full course video with what Docker is, then we will look into the services and components of Docker in detail. Next, we will see what Docker container is and what are the basic commands of a Docker container. Then, we will focus on Docker Swarm and Docker Compose. After that, we will discuss everything about Docker networking. Then, we will see how to install Docker on Ubuntu and Windows 10. Next, we will talk about 12 crucial Docker interview questions and answers for beginners and experienced candidates. Finally, we will conclude this video by discussing the differences between the two famous tools, which are Docker and Kubernetes. By the end of this video, I can assure you that all your Docker query-related queries will have been answered. Let's dive deep and learn about these important tools of DevOps. So, without further ado, let's get started.
Hello, this is Matthew from Simply Learn, and today we're going to cover what is Docker and why it should be of value to you as somebody who works in DevOps. So let's take a little scenario of a developer and a tester before you had the world of Docker. A developer would actually build their code and then they send it to the tester, but then the code wouldn't work on their system. The code doesn't work on the other system due to the differences in computer environments. So what could be the solution to this? Well, you could go ahead and create a virtual machine to be the same of the solution in both areas. But we think Docker is an even better solution. So let's kind of break out what the main big differences are between Docker and virtual machines. As you can see between the left and the right hand side, both look to be very similar. What you'll see, however, is that on the Docker side, what you'll see as a big difference is that the guest OS for each container has been eliminated. Docker is inherently more lightweight, but provides the same functionality as a virtual machine. So let's step through some of the pros and cons of a virtual machine versus Docker. So first of all, a virtual machine occupies a lot more memory space on the host machine. In contrast, Docker occupies significantly less memory space. The boot up time between both is very different. Docker just boots up faster. The performance of the Docker environment is actually better and more consistent than the virtual machine. Docker is also very easy to set up and very easy to scale. The efficiencies, therefore, are much higher with a Docker environment versus a virtual machine environment. And you'll find it is easier to port Docker across multiple platforms than a virtual machine. Finally, the space allocation between Docker and a virtual machine is significant. When you don't have to include the guest OS, you're eliminating a significant amount of space, and the Docker environment is just inherently smaller. So after Docker, as a developer, you can build out your solution and send it to a tester. And as long as we're all running in the Docker environment, everything will work just great. So let's step through what we're going to cover in this presentation. We're going to look at the DevOps tools and where Docker fits within that space. We'll examine what Docker actually is and how Docker works. And then finally, we'll step through the different components of the Docker environment. So what is DevOps? DevOps is a collaboration between the development team and the operation team, allowing you to continuously deliver solutions and applications and services that both delight and improve the efficiency of your customers. If you look at the Venn diagram that we have here, on the left-hand side we have development, on the right-hand side we have operation, and then there's a crossover in the middle, and that's where the DevOps team sits. If we look at the areas of integration between both groups, Developers are really interested in planning, code, building, and testing, and operations want to be able to efficiently deploy, operate, and monitor. When you can have both groups interacting with each other on these 7 key elements, then you can have the efficiencies of an excellent DevOps team. So planning and codebase, we use tools like JIT and Gira. For building, we use Gradle and Maven. Testing, we use Selenium. The integration between Dev and Ops is through tools such as Jenkins. And then the deployment operation is done with tools such as Docker and Chef. Finally, Nagios is used to monitor the entire environment. So let's step deeper into what Docker actually is. So Docker is a tool which is used to automate the deployment of applications in a lightweight container so the application can work efficiently in different environments. Now, it's important to note that the container is actually a software package that consists of all the dependencies required to run the application. So multiple containers can run on the same hardware. The containers are maintained in isolated environments. They're highly productive and they're quick and easy to configure. So let's take an example of what Docker is by using a house that may be rented for someone using Airbnb. So in the house, there are 3 rooms and only 1 cupboard and kitchen. And the problem we have is that none of the guests are really ready to share the cupboard and kitchen, because every individual has a different preference when it comes to how the cupboard should be stocked and how the kitchen should be used. This is very similar to how we run software applications today. Each of the applications could end up using different frameworks. So you may have a framework such as Rails, Perfect, and Flask, and you may want to have them running for different applications for different situations. This is where Docker will help you run the applications with the suitable frameworks. So let's go back to our Airbnb example. So we have 3 rooms and a kitchen and cupboard. How do we resolve this issue? Well, we put a kitchen and cupboard in each room. We can do the same thing for computers. Docker provides the suitable frameworks for each different application. And since every application has a framework with a suitable version, this space can also then be utilized for putting in software and applications that along. And since every application has its own framework and suitable version, the area that we had previously stored for a framework can be used for something else. Now we can create a new application, in this instance a 4th application that uses its own resources. You know what? With these kinds of abilities to be able to free up space on the computer, it's no wonder Docker is the right choice. So let's take a closer look to how Docker actually works. So when we look at Docker and we call something Docker, we're actually referring to the base engine, which actually is installed on the host machine that has all the different components that run your Docker environment. And if we look at the image on the left-hand side of the screen, you'll see that Docker has a client-server relationship. There is a client installed on the hardware. There is a client that contains the Docker product, and then there is a server which controls how that Docker client is created. The communication that goes back and forth to be able to share the knowledge on that Docker client relationship is done through a REST API. And this is fantastic news because that means that you can actually interface and program that API. So we look here in the animation, we see that the Docker client is constantly communicating back to the server information about the infrastructure, and it's using this REST API as that communication channel. The Docker server then will check out the requests and the interaction necessary for it to be the Docker daemon, which runs on the server itself, will then check out the interaction and the necessary operating system pieces needed to be able to run the container. Okay, so that's just an overview of the Docker engine, which is probably where you're going to spend most of your time. But there are some other components that form the infrastructure for Docker. Let's dig into those a little bit deeper as well. So what we're going to do now is break out the 4 main components that comprise of the Docker environment. The 4 components are as follows: the Docker client and server, which we've already done a deeper dive on, Docker images, Docker containers, and the Docker registry. So if we look at the structure that we have here, on the left-hand side, you see the relationship between the Docker client and the Docker server. And then we have the REST API in between. Now, if we start digging into that REST API, particularly the relationship with the Docker daemon on the server, we actually have our other elements that form the different components of the Docker ecosystem. So the Docker client is accessed from your terminal window. So if you are using Windows, it's going to be PowerShell. On Mac, it's going to be your terminal window. And it allows you to run the Docker daemon and the registry service. When you have your terminal window open, so you can actually use your terminal window to create instructions on how to build and run your Docker images and containers. If we look at the images part of our registry here, we actually see that the image is really just a template with the instructions used for creating the containers which you use within Docker. The Docker image is built using a file called the Docker file. And then once you've created that Docker file, you'll store that image in the Docker Hub or registry. And that allows other people to be able to access the same structure of a Docker environment that you've created. The syntax of creating the image is fairly simple. It's something that you'll be able to get your arms around very quickly. And essentially what you're doing is you're creating the option of a new container. You're identifying what the image will look like, what are the commands that are needed, and the arguments for within those commands. And once you've done that, you have a definition for what your image will look like. So if we look here at what the container itself looks like, is that the container is a standalone executable package which includes applications and their dependencies. It's the instructions for what your environment will look like. So you can be consistent in how that environment is shared between multiple developers, testing units, and other people within your DevOps team. Now, the thing that's great about working with Docker is that it's so lightweight that you can actually run multiple Docker containers in the same infrastructure and share the same operating system. This is its strength. It allows you to be able to create those multiple environments that you need for multiple projects that you're working on. Interestingly though, within each container, that container creates an isolated area for the applications to run. So while you can run multiple containers in an infrastructure, each of those containers are completely isolated. They're protected so that you can actually control how your solutions work there. Now, as a team, you may start off with 1 or 2 developers on your team, but when a project starts becoming more important and you start adding in more people to your team, you may have 15 people that are offshore, you may have 10 people that are local, you may have 15 consultants that are working on your project. You have a need for each of those developers or each person on your team to have access to that Docker image. And to get access to that image, we use the Docker registry, which is an open source server-side service for hosting and distributing the images that you have defined. You can also use Docker itself as its own default registry and Docker Hub. Now, something that has to be very in mind though is that for publicly shared images, you may want to have your own private images, in which case you would do that through your own registry. So once again, public repositories can be used to host the Docker images, which can be accessed by anyone. And I really encourage you to go out to Docker and see the other Docker images that have been created, because there may be tools there that you can use to speed up your own development environments. Now, you will also get to a point where you start creating environments that are very specific to the solutions that you are building. And when you get to that point, you'll likely want to create a private repository so you're not sharing that knowledge with the world in general. Now, the way in which you connect with the Docker registry is through simple pull and push commands that you run through terminal window to be able to get the latest information. So if you want to be able to build your own container, what you'll start doing is using the pull commands to actually pull the image from the Docker repository. And the command line for that is fairly simple. In terminal window, you would write docker pull, and then you put in the image name and any tags associated with that image and use the command pulls. So in your terminal window, you would actually use a simple line of command once you've actually connected to your Docker environment. And that command will be docker pull with the image name and any associated tags around that image. What that will then do is pull the image from the Docker repository, whether that's a public repository or a private one. Now, in reverse, if you want to be able to update the Docker image with new information, you do a push command where you would take the script that you've written about the Docker container that you define and push it to the repository. And as you can imagine, the commands for that are also fairly simple. In terminal window, you would write docker push the image name, any associated tags, and then that would then push that image to the Docker repository. Again, either a public or a private repository. So if we recap, the Docker file creates a Docker image that's using the build commands. A Docker image then contains all of the information necessary for you to be able to execute the project. Using the Docker image, any user can run the code in order to create a Docker container. And once a Docker image is built, it's uploaded to a registry or to a Docker hub where it can be shared across your entire team. And from the Docker hub, users can get access to the Docker image and build their own new containers. So let's jump into our first section of life before Kubernetes. So the way that you have done work in the past, or you may be doing work right now, is really building out and deploying solutions into two distinct areas. One is a traditional deployment where you're pushing out code to physical servers in a data center, and you're managing the operating system and the code that's actually running on each of those servers. Another environment that you may potentially be using is deploying code out to virtual machines. So let's go through and look at the two different types of deployment that you may be experiencing. When you have applications running on multiple machines, you run into the potential risk that the setup and configuration of each of those machines isn't going to be consistent and your code isn't going to work effectively, and there may be issues with uptime and errors within the infrastructure of your entire environment. There's going to be problems with resource allocation, and you're going to have issues where applications may be running effectively and not effectively and not load balanced effectively across the environment. The problem that you have with this kind of infrastructure is that it gets very expensive. You can only install one piece of software, one service on one piece of hardware, so your hardware is being massively underutilized. This is where virtual machines have become really popular. With a virtual machine, you're able to have better resource utilization and scalability at much less cost. And this allows you to be able to run multiple virtual machines on a single piece of hardware. The problem is that VMs, for virtual machines, are not perfect either. Some of the challenges you run with VMs is that the actual hardware and software needed to manage the VM environment can be expensive. There are security risks with VMs. There are security risks with VMs. There have been data breaches recorded about solutions that run in virtualized environments. You also run into an issue of availability, and this is largely because you can only have a finite number of virtual machines running on a piece of hardware. And this results in limitations and restrictions in the types of environment you want to be running. And then finally, setting up and managing a virtualized environment is time consuming. It can take a lot of time, and it can also get very expensive. So how about Kubernetes? Well, Kubernetes is a tool that allows you to manage containerized deployment of solutions. And inherently, Kubernetes is a tool that is really a next level maturity of deployment. So if you can think of your maturity curve as deploying code directly to hardware in a data center, and then deploying your solutions to virtual machines, the next evolution of that deployment is to use containers and Kubernetes. So let's kind of go through and look at the differences between a virtual machine and Kubernetes. And we've got a few here that we want to highlight, and you'll get an understanding of what the differences are between the two. So first of all, with virtual machines, there is inherently security risks. And what you'll find as we dig through the architecture later in the presentation is that Kubernetes is inherently secure. And this is largely because of the legacy code, the legacy of Kubernetes and where it came from. And we'll talk about that in just a moment. But Kubernetes is inherently secure. Virtual machines are not easily portable. Now, with that said, they are technically portable. They're just not very easily portable. Whereas with Kubernetes, it's working with Docker container solutions. It is extremely portable. That means that you can actually spin up and spin down and manage your infrastructure exactly the way that you want it to be managed and scale it on the demands of the customers as they're coming in to use the solution. From a time-consuming point of view, Kubernetes is much less time-consuming than with a virtual machine. A few other areas that we want to kind of highlight from differences. Virtual machines use much less isolation when building out the encapsulated environment than Kubernetes does. For instance, with a virtual machine, you have to run hypervisor on top of the OS and hardware, and then inside of the virtual machine, you also have to have the operating system as well. Whereas in contrast, on a Kubernetes environment, because it's leveraging Docker container or container-like technologies, it only has to have the OS and the hardware, and then inside of each container, it doesn't need to have that additional OS layer. It's able to inherit what it needs to be able to run the application. This makes the whole solution much more flexible and allows you to run many more containers on a piece of hardware than versus running virtual machines on a single piece of hardware. So as we highlighted here, VMs are not as portable as Kubernetes, and Kubernetes is portable directly related to the use of containerization. And because Kubernetes is built on top of containers, it is much less time consuming because you can actually script and automatically allocate resource to nodes within your Kubernetes environment. This allows the infrastructure to run much more effectively and much more efficiently. So this is why, if we look at our evolution of the land of time before Kubernetes, why we are running into a solution where Kubernetes had to come about, because the demand for having more highly scalable solutions that are more efficient was just really a natural evolution of this software deployment model that started with pushing out code to physical hardware and then pushing code out to virtual machines and then needing to have a solution much more sophisticated. Kubernetes would have come about at some point in time. I'm just really glad it came about when it did. So what is Kubernetes? Let's dig into the history of Kubernetes and how it came about. So in essence, Kubernetes is an open source platform that allows you to manage and deploy and maintain groups of containers. And a container is something like Docker. And if you're developing code, you're probably already using Docker today. Consider Kubernetes as the tool that manages multiple Docker environments together. Now, we talk a lot about Docker as a container solution with Kubernetes. The reality is that Kubernetes can actually use other container tools out there, but Docker just simply is the most popular container out there. Both these tools are open source. That's why they're so popular. And they just allow you to be able to have flexibility in being able to scale up your solutions. And they were designed for the post-digital world that we live and exist in today. So a little bit of background, a little bit of trivia around Kubernetes. So Kubernetes was originally a successor to a project at Google, and the original project was Google Borg. Google Borg, it does exactly what Kubernetes does today, but Kubernetes was rewritten from the ground up and then released as an open source project in 2014 so that people outside of Google could take advantage of the power of Kubernetes containerization management tools. And today it is managed by the Cloud Native Computing Foundation. And there are many companies that support and manage Kubernetes. So for instance, if you're signing up for Microsoft Azure, AWS, Google Cloud, all of them will leverage Kubernetes, and it's just become the de facto tool for managing large groups of containers. So let's kind of step through some of the key benefits that you would experience from Kubernetes. So we have 9 key benefits. The first, it is highly portable. It is 100% open source code. And this means that you can actually go ahead and contribute to this code project if you want to through GitHub. The ability to scale up the solution is incredible. What's the history of Kubernetes being part of a Google project for managing the Google network and infrastructure kind of really sets the groundwork for having a solution that is highly scalable. The out of the high scalability also comes the need for high availability. And this is the desire to be able to have a highly efficient and highly energized environment that also you can really rely on. So if you're building out a Kubernetes management environment, you know that it's going to be available for the solutions that you're maintaining. And it's really designed for deployment. So you can script out the environment and actually have it as part of your DevOps model so you can scale up and meet the demands of your customer. Then what you'll find is that the load balancing is extremely efficient, and it allows you to distribute the load efficiently across your entire network so your network remains stable. And then also the tool allows you to manage the orchestration of your storage. So you can have local storage such as an SSD on the hardware that the Kubernetes is maintaining. Or if the Kubernetes environment is pulling storage from a public cloud such as Azure or AWS, you can actually go ahead and make that available to your entire system. And you can inherit the security that goes back and forth between the cloud environments. And one of the things you'll find consistent with Kubernetes is that it is designed for a cloud-first environment. Kubernetes as well is that it's really a self-healing environment. So if something happens or something fails, Kubernetes will detect that failure and then either restart the process, kill the process, or replace it. And then because of that, you also have automated rollouts and rollbacks in case you need to be able to manage the state of the environment. And then finally, you have automatic bin packaging, so you can actually specify the compute power that's being used from CPU and RAM for each container. So let's dig into the final area, which is the actual Kubernetes architecture. And we're going to cover this at a high level. There's actually another video that you can that Simplilearn has developed, which digs deeper into the Kubernetes architecture. And so the Kubernetes architecture is a cluster-based architecture, and it's really about two key areas. You have the Kubernetes master, which actually controls all of the activities within your entire Kubernetes infrastructure. And then you have nodes that actually are running on Linux machines that are controlled by the master. So let's kind of go through some of these areas. So if we look at the Kubernetes master to begin with, we'll start with etc. This is a tool that allows for the configuration of information and the management of nodes within your cluster. And one of the key features that you'll find with all of the tools that are managed within either the master environment or within a node is that they are all accessible via the API server. And what's interesting about the API server is that it's a RESTful based infrastructure, which means that you can actually secure each connection with SSL and other security models to ensure that your entire infrastructure and the communication going back and forth across your infrastructure is tightly secured. Scheduler goes ahead and actually, as you'd expect, it actually manages the schedule of activities within the actual cluster. And then you have the controller, and the controller is a daemon server that actually manages and pushes out the instructions to all of your nodes. So the other tools really are the infrastructure, and you can consider them the administration side of the master, whereas controller is the management. It actually pushes out all of the controls via the API server. So let's actually dig into one of the actual nodes themselves, and there are three key areas of the nodes. One is the Docker environment, which actually helps and manage and maintain the container that's actually inside of the node. And then you have the kubelet, which is responsible for information that goes back and forth, and it's going to do most of the conversation with the API server on the actual health of that node. And then you have the actual Kubernetes proxy, which actually runs the services actually inside of the node. So as you see, all of these infrastructures are extremely lightweight and designed to be very efficient and very available for your infrastructure. And so here's a quick recap of the different tools that are available. And it really breaks down into two key areas. You have your Kubernetes master and the Kubernetes node. The Kubernetes master has the instructions of what's going to happen within your Kubernetes infrastructure. And then it's going to push out those instructions to an indefinite number of nodes that will allow you to be able to scale up and scale down your solution in a dynamic way.
Today I'll be taking you through the installation process for Docker. So now let's begin with the demo. We'll be installing Docker on an Ubuntu system. So this is my system. I just open the terminal So the first thing you can start with is removing any Docker installation that you probably already have present in your system if you want to start from scratch. So this is the command to do so. Sudo apt-get remove docker engine docker.io. Enter your password and Docker is removed. So now we'll start from scratch and we'll install Docker once again. Before that, I'll just clear my screen. Okay, so before I install Docker, let me just ensure that all the softwares on my system currently is in its latest state. So sudo apt-get update. Great, so that's done. Next thing, we'll actually install our Docker. So type in sudo apt get install Docker. Now as you can see here, there's an error that's occurred. So sometimes it's possible that due to the environment of the machine that you're working in, this particular command does not work. In which case, there's always another command that you can start with. You just type docker install. And that by itself will give you the command you can use to install Docker. So as it says here, sudo apt install docker.io is a command that we will need to execute to install Docker. And after that, we'll execute the sudo snap install Docker. So sudo apt install docker.io first. And this will install your Docker. After that's done, we will have sudo snap install Docker. So snap install Docker installs a newly created snap package. They are basically some other dependencies for Docker that you'll have to install. Of course, since this is the installation process for the entire Docker IO, it will take some time. Great, so our Docker is installed. The next thing we do, as I mentioned earlier, is that we need to install all the dependency packages. So the command for that is sudo snap install Docker. Enter your password. So with that, we have completed the installation process for Docker, but we'll perform a few more stages where we will test if the installation has been done right. So before we move on with the testing for Docker, let's once again just check the version that we have installed. So for that, the command is docker version. And as you can see, Docker version 17.12.1 CE has been installed. Next thing we do is we pull an image from the Docker hub. So docker run hello world. Now hello world is a Docker image which is present on the Docker hub. Docker hub is basically a repository that you can find online. So with this command, the Docker image hello world has been pulled onto your system. So let's see if it's actually present on your system now. the command to check this is sudo docker images. And as you can see here, hello world repository, this is present on our system currently. So the image has been successfully pulled onto the system, and this means that our Docker is working. Now we'll try out another command. Sudo docker ps -a. This displays all the containers that you have pulled so far. So as you can see here, there are 3 hello world images displayed, and all of them are in exited state. So I did this demo previously too, which is why the 2 hello worlds which is created 2 minutes ago is also displayed here. And the first hello world which has been created a minute ago is the one we just did for this demo. Now, as you have probably noticed that all the hello world images over here, all these containers are in the exited state. So when you give the option for docker ps -a, where -a stands for all, it displays all the containers whether they are in exited or running state. If you want to see only those containers which are in their running state, you can simply execute sudo docker ps. Sudo docker ps. And as you can see, no container is visible here because none of them are in running state.
Welcome everyone to our another demo on which we are going to see that how exactly we can do the installation of Docker on the Windows platform, specifically on Windows 10. Now Docker is something which is available for most of the operating systems, different platforms. So it supports both the Unix and the Windows platform as such. So Linux, through various commands we can do the installation, but in the case of Windows you have to download the exe file and a particular installer from the Docker Hub websites. You can simply Google it and you will get a kind of a link from where you will be able to download the package. So let's go to the Chrome and try to search on for the Windows 10 particular installer. You will get a link from Docker Hub. You download it, you get the stable version, you get the Edge version, whichever version you wish to download, you can download it. So let's go back to the Chrome. So here you have the Docker desktop for Windows, so you can go for the stable or you can go for the Edge, right? So you also have the comparison that what is the difference between these two versions, right? So the particular Edge version is something which is getting releases every month, and the stable version is getting the releases every quarter. So they are not doing much of the changes to the stable version as compared to the Edge there. So you just have to double click on the installer and that will help you to do the installation of the process. So let's get started. So you just click on the get in stable version. So when you do that, the particular installer is going to install. Now it's going to take like around 300 MB there. So that's the kind of installer which is available. So once the installer is downloaded, so what you can do is that you can actually go ahead and you can proceed with doing the double click on this installer. When you double click on that, you have to proceed with some of the steps, like from the GUI itself you are going to proceed with these steps. So we'll wait for 10 to 20 seconds more and then the installer will be done, and then we can do the double click and the installation will proceed. So another thing is that there is a huge difference between the installer. Like for example, in case of Unix, the installer is a little bit less, but in case of Windows, it's a GUI is also involved, and there are a lot of binaries which is available there. So that's the reason why the huge size is there. Now it's available for free, that's for sure, and it also requires the Windows 10 Professional or Enterprise 64-bit there. So if you are working on some previous version of operating systems like Windows 7 and all, you have the older version called Docker Toolbox. So they used to call it as like Docker Toolbox earlier, but now they are calling it as a Docker Desktop with the new Docker Windows 10 support as such here. So another couple of seconds and then the installer will be done, and then we will be able to proceed with the installation. So let's see that how much progress is there to the download. So we'll click on the downloads, and here still we have some particular installations or some download going on. So we'll wait for some time, and once the installation is done, then we'll go back and we'll proceed with installation. So couple of seconds. So it's almost done. So I'll just click on this one. You can go to the directory, to the downloads, and you can double click on that also. But if you want to do the installation, you can click on this one also, and it will ask for the approval, yes or no, you have to provide. Now once that is done, so a desktop, a kind of a GUI component will open there, so it will start proceeding with the installation. So it's asking whether you want to add a desktop, the shortcut to desktop, so you can say okay. I'm going to click on OK, so it will unpack the files, all the files which is required for Docker to successfully install. That is getting unpacked over here. So it will take some time to do the installation because it's doing a lot of work here. So you can just wait for till the execution of the installer to be completed. And once the installer is done, you can open your command line and start working on the Docker. So taking some time to extract the files. Now it's asking us to do the close and do the restart. So once that is done, you will be able to proceed further, and you can just run the command line, and any Docker command if you can run, so that will give you the response whether the Docker is installed or not. So you can see here that Docker is something which is installed, so you can run like Docker version. You will be able to get a version of the client. When you do the restart of the machine, then at that moment of time the Docker server will also be started, and then this particular error message will go off. Right now the Docker daemon is not up and running because the installation requires a restart, and when you close on this one and go for the restart, the machine will be restarted here. So this is the way that how exactly we can go for a Docker installation, and we can go on that part. Now let's start with what exactly is in DevOps all about here. Now DevOps is nothing but a collaboration between the development and the operations teams over here, which enables continuous delivery of the applications and services to the end user. So it's a combination or collaboration between the two teams, development and operations, which helps us to go for a further implementation of various processes like continuous integration, continuous deployment, continuous delivery. All these things are possible with this collaboration over here. Now why exactly Docker is important for us as such? In a city far away from this one, so a developer decided to develop a tons of software on a single VM. Now he can put up applications. He is having a big server and he wants to host the multiple applications on a single machine. But for him, the virtual machine got a crash, because definitely if you are putting up more different applications as such on a single VM, it's not able to take up that much kind of load over there. So in order to avoid this situation, how exactly he can do the various options, or what he can implement to have this issue resolved. So ultimately Docker is something which is the solution of him. So if he really wants to host multiple applications on a single virtual machine, or he want to have different applications, then Docker is the ultimate solution for him to do that. And by doing so, there will be no issues as such when we talk about that the errors or the virtual machines cannot be crashed, and there will be no impact on the virtual machine as such. So why exactly Docker is important? So let's talk about the comparison between the Docker and virtual machine. There are very few reasons why exactly the Docker is being chosen over a virtual machine, because virtual machine is a full-fledged component which can take up any kind of load. But some of the reasons are still that in which case we will be preferring the Docker instead of the virtual machine here. The very first one is the memory uses. So Docker is having a very less memory uses because there is no concept of guest operating system, whereas on the other hand the virtual machines are going to take a huge amount of RAM resources in order to keep that particular operating system up and running. Second one, performance, because if you have less utilization and the users is less, the performance will be better. But for some reason, if you are taking up more resources, and you will not be able to deliver that amount of performance as such over there. And then again we have portability. So portability is also quite easy when we talk about the virtual machines. In case of Docker, it's quite portable as compared to the virtual machine. And then the last time is that the boot up time. So virtual machine boot up time is probably in minutes, but in case of Docker it's in seconds. So if we summarize it on this one, so the memory utilization, the boot up time, the performance, everything is better in case of Docker as compared to the virtual machines, right? For a classic example, let's say that what about the memory user? 9 GB of memory, is something. If you can see that app1, app2, and app3 is there. So green and red color represents the occupied memory and the wasted memory. Now there is a particular utilization of, let's say that a server which is available there, and 3 GB of RAM is something which is wasted, and 4 GB of RAM is something which is being occupied there. So app 2 is using like 2 GB, and then you can see that the specific 2 GB of RAM is occupied and 3 GB is occupied, and the wasted one is 1 GB. So VM can see over there that 9 GB of RAM is used, and the remaining 6 GB of unused RAM cannot be reused here, because if, for example, I allocate like 4 GB of RAM to the virtual machine, it's there itself. It gets logged on. So it's not like, okay, I'm using only 4 GB RAM out of this 9 GB of RAM, then the next 5 GB of RAM will be totally wasted. So you cannot reuse it for any purpose. So this is a problem with the virtual machine, that if you allocate some memory to the specific virtual machine, if you are not using that much resources or that much memory, the remaining memory will be simply wasted, because this is hardcorely allocated to the virtual machine, and you cannot utilize this unused memory as such over there. So this is the limitation from the memory perspective. But in case of Docker, definitely, if out of the 9 GB of RAM, if we are using only 3 GB of RAM, so whatever the unused memory is there, so we can actually reuse it for the new containers. So it's not dedicatedly allocated to the virtual machines. If you are using out of 9 GB, if you are using 1 GB, 2 GB, 3 GB, or 4 GB, whatever the remaining memory is available, that you can simply use it for the other containers also. This ensures that you always go for an optimal utilization of your resources, and unnecessarily there is no wastage of the different resources or the different components over here in this one. So that's the reason why the Docker containers are quite efficient in terms of memory when we compare it with the virtual machine. Next one is the performance. Now in a virtual machine, we know that on the infrastructure, on the physical infrastructure, on top of that you put up a kind of operating system. A base operating system is there, and then on top of that you have the hypervisor, and this hypervisor then is used to create the virtual machines, which is having a kind of guest operating system inside it. Now the issue over here is that you have two operating systems over here. So the guest operating system is also going to take some particular resources, and for example, the memory or a space, a processor. So in every resource terms, it is going to go ahead and say that okay, I'm going to use the particular some of the resources. Now problem is that if you are hosting a very small application, you will end up in having a more consumption, because of this guest operating system will take more of the resources, and then you are just using some very small resources for your application in an real world. So Docker container, on the other hand, does not have a concept of the guest operating system, and that's where what happens, that the Docker engine is more than sufficient to handle the Docker containers, and inside the Docker containers there is the application which is being hosted over there. Now with this one, definitely the performance is quite better as compared to any virtual machine, because of the terms that there is no unnecessarily wastage of the resources. Because in the previous case, virtual machines, a full-fledged guest operating system is up and running, you need some resources to be allocated to that. But in case of containers, you don't need to have that particular functionality implemented. Then portability. So having a portability or moving an application which works on a system A does not mean that it will work on the system B also. This is a similar problem which we face, that usually the application works perfectly fine in a lower environment, and when it goes to the production environment, it sometimes fails, and it does not comes up properly. So this is an portability issue which we have when we talk about the virtual machines. But when in case of containers, when we got a container up and running in a lower environment, and once the container is prepared, you don't have to do the changes or modification to that depending on the environment. The same container can be deployed to production environment, and it's very easy. So whatever container prepared in the lower environment, in a dev environment, the same will work in production environment without any issues, because it contains all the dependencies and executables, everything inside it. So you don't have to do any kind of modifications or changes to these containers as such over here. And the last one is the boot up time. So the boot up time of the virtual machines is in minutes, and whereas the boot up time of the Docker containers is in seconds or probably in milliseconds. So these are the reason why we consider the virtual machine as an resources based environment. But on the other hand, Docker is something which is quite light and fast as compared to virtual machines. So let's see that what exactly is in Docker all about here. So in this one, you can see we have the physical infrastructure on which we have the host operating system. Now we don't have the hypervisor and the guest operating system. Instead of that, we have the Docker engine, which is taking care of managing the Docker containers. And inside these Docker containers, you have the applications and all the required binaries and the libraries here. So there is no concept of the guest operating system. This Docker engine is the person or is the process which is taking care of all the requests which is going on, and if this Docker engine is up and running, then all the containers will also be accessible and will be available. Now Docker is nothing but a OS level virtualization software platform that enables developers and IT administrators to create, deploy and run applications in a Docker container with all its dependencies. So Docker is a very important tool nowadays if you want to look forward to host your application, because of its portability benefit that you don't require much of the changes depending on the platform or depending on the environment. So whatever the developers are able to build up, the same thing will go till the production environment. Now let's talk about what exactly is in Docker container here. Now Docker container is a lightweight software package that includes all the dependencies, whether it's a base operating system, some framework, some libraries. It's something which is a part of this one, so that if you will be if you want to host your application, you will be able to do that. So it's a complete package. So both the source code and the dependencies is what you put up inside the Docker containers. Now within this Docker containers, you can have multiple applications there, multiple programming languages, multiple frameworks can be hosted there. In fact, the databases also can be hosted within this Docker containers. You can host them as such over there. Now, what are the different advantages of Docker? Let's talk about that. Now, the first one is the rapid deployment. So, rapid deployment is the very first advantages which we are getting over here. Second, quick and easy configuration, better efficiency, portability, scalability, and security over here. Now there are different ways in which we can understand the benefits, or we can have the understanding about the Docker here. So these are some couple of benefits. Now let's take them one by one. The first one is the deployment part. So it supports the rapid deployment. Now just like a web application, for instance, I want to deploy to website, so there are some couple of steps which needs to be done across different environments. Like for example, if I have 5 environments, I have to do the deployment, the same steps in all the 5 environments at the different period of time. Now when we talk about Docker containers, we don't have to run those steps multiple times, because once those steps are executed in one Docker container, the same Docker container goes till the production environment. So you don't have to actually do a rebuild of the Docker containers, and you can simply say that, okay, I have got the Docker container here, so you can just run one or two couple of commands and that will help you to host your Docker containers. So you don't have to redo or rework on any kind of the deployment work into the production environment or into the higher environments. And then we goes for the quick and easy configurations. So the configurations of Docker containers is quite easy. You can have your own custom Docker images built out the Docker files. So these processes can be integrated within the Jenkins also. So CI/CD is quite possible with the help of Docker if you want to really do that. And then we have better efficiency. Yes, they have a better efficiency and resources management as compared to the virtual machines. Portability, we have already talked about that it's easy to move from one environment, from one system to another. In fact, it's easy from the developer also. So from one machine, from one developer to another developer, it's very easy to move these different Docker containers. Then we have scalability. Scalability is also possible with these Docker containers. Just like multiple virtual machines, you can also create multiple containers and you can share the traffic out of that. So, but that scalability and all is possible with the orchestration tools. Then security is there, so you can have your best practices of the security implemented, because it's just a kind of a virtualization, just like a virtual machine. So you have all the different possibilities which is available, which you can explore when you want to make these Docker containers secure, right? So these were some of the benefits which was there for the Docker here. Now let's talk about the installation of Docker here. Now, installation of Docker is pretty common, and whatever platform you want, it's available over there. So it's available for Ubuntu, Windows. It's available for Mac operating system. So for Ubuntu, you have to run the commands on the Ubuntu operating system to download it. And for Windows, it's actually having a particular exe file, so you can go for the installation of exe file. And then we have the Mac operating system. So for Mac operating system, you have the DMG files, and when you do the DMG file, so it will help you to install the component over there. So Mac, you can also use the homebrew once to do the installation of that particular component. Now next one is the architecture of Docker. Now the architecture of Docker is pretty straightforward. There are key components which is available there in the architecture of Docker here. The very first one is as the client facing is the Docker client. Now Docker client, or you can say the Docker CLI, is available there. Now this is the component, it's a command line interface which takes up the request from the end user. Like for example, I'm running the command, so it will take all the requests from me as an end user, and it will send those particular things or the requirements to the Docker daemon, to the server, using the REST API interface. So this Docker daemon is something which keeps on running on the server, and it's a background process. It gets deployed as a service there. In case this Docker daemon is not available or it's not up and running, you will not get the proper response from the Docker command line here. So in order to get your activity or your procedures implemented, you need to have the Docker server or Docker daemon up and running. In fact, this Docker CLI can be configured to connect to any other servers or any other different server Docker daemon also. So it's a connectivity which is happening over the REST API interface, where all the requests are processed, are sent to the Docker daemon, and whatever response is coming back, that is given back to the end user. So what are the different components of Docker here? Let's talk about that. So Docker client consists of the CLI component, like we have already discussed. So that is something which is going to take up all the requests from the end user. Then it's using the REST API interface, which is there to have the connectivity with the Docker daemon. So Docker daemon is something which is always up and running. So if you run couple of commands like docker pull, push, and also that activity, you are actually sending the request to the Docker daemon, and Docker daemon is actually doing all the work. So it's not a Docker client which is doing it, just taking, it's kind of an interface which will take the things up and send it back or send it forward to the Docker day. Right, so it's a background process which keeps on running on the server, on the operating system, and it's the same process across all the infrastructure, all the different platforms, whether you use Mac operating system, you use Windows, or you use Linux. Everywhere this is the basic functionality, and it keeps on listening to the REST API interface. So whatever the new request comes in, it immediately processes it, and whatever the response, whether you are stopping a container, whether you are running a container, according to that the action will be taken, and the response will be sent back to the REST API to the Docker client. So a Docker is a process, or it's a command line which is used to start the Docker daemon. When you run the command like service docker status on the server, you will be able to see the command which is getting executed in the backend. So there you can see that Docker is the process, or is the command line which is used to initialize the Docker daemon. And of course there is a kind of configurations which you have to pass it on as parameters. So even if you run ps-ef command, you will be able to know that what process is running from the Docker perspective. And the third component is a particular Docker registry. So we have a ready-made cloud service which is available, known as the Docker Hub. So you can actually store the Docker images on these Docker registry. So there are a lot of ready-made Docker images which is available there, but of course you can have your own Docker image also over there, or you can have your own custom registry, Docker registries also. For example, in JFrog you can have your private hosted registries also. So all these different repositories you can use with your Docker containers. So Docker containers is having the flexibility that whichever registries or repositories you want to connect, or you want to establish the connectivity, you can always do that. Now let's talk about the Docker image over here in detail. Now a Docker image is nothing but a template of instructions. It's having a couple of instructions in which you will be using these instructions to create a final Docker container. So Docker image is nothing but, for example, I want to have a Tomcat Apache Docker image. So what are the instructions I have to do? So the very first thing is that I have to pick up a base operating system. Then on top of that, I will be installing the JDK or some prerequisite packages. And then on top of that, we will be configuring onto the Tomcat Apache there. So these are the steps. These are the different instructions, step-by-step procedure, which we are implementing so that at the end of the activity, we will be able to have a Docker container ready, which we can deploy to host Tomcat Apache. So it's a template which is having all the particular instructions. In order to build a Docker image, you require a file called Docker file, which is of course having all these different instructions embedded in that. So when you run the Docker file, it acts like a build tool. So whatever the instructions you are putting up over there, all those instructions are getting processed, and you are able to get an end result. Then these Docker images are actually comprised of multiple layers. So multiple layers are available there. So step by step, so you will be first of all having a base layer from which the image starts. On top of that, another layer. For example, you did the installation of JDK, so another layer will be there, and then you did the configuration of the Tomcat Apache, and then another layer will be there. So it's a multi-layered in component which is available, and these layers are in incremental order. So definitely the oldest one will be known as the base layer, and then on top of that, all the latest changes will be done in the latest layers there. So this is an example. Now here you can see that there are 4 instructions, and these 4 instructions are also known as the 4-layered Docker image. So whatever the final Docker image you will get, in there you will be able to see 4 layers of the Docker image here. Now the very first is Ubuntu. So Ubuntu 18.04 we are pulling up, and then we are pulling like the file over here, and then we are running the make utility, and once that is done, then we are running that file.python file over here in this one. So these are 4 instructions which is available, right? So which will definitely help us to do that, how exactly we can make or we can perform the different activities right from the base. So in this case, the base layer will be like the Ubuntu one. So Ubuntu one will be the base image, and the moment the final CMD attribute or CMD attributions are processed and executed, after that you will be able to get a final full-fledged Docker image over there. So this will be a full complete Docker image or Docker container which you will get once the whole build process is completed. Now in this ways, you have you can see that the previous Docker file which we processed, so the base layer is Ubuntu 18.04. we are not building that, actually it's automatically it's by default getting downloaded as a full base layer. After that only we have like layer 1, layer 2, layer 3 added up, because those modifications we are doing it after the because from does not means that you are doing any kind of layer modifications. It's just like you are importing some base operating system or base image. So the modification or adding up the layers is only done after the base layer there. So whenever a user creates a container, a new layer is something which is stored on top of the image. These layers are known as the containers layers. So Ubuntu one, the very first instruction does not comprises it. It's not a kind of container layer. We can call it as an base image layer there. So every container has a separate read-write container layer, and any modification in a container is reflected upon the container layers only. So layer 1 may be having some different of instructions. Layer 2 may be having different instructions. So like that is a step-by-step processor. In case, whenever a container is deleted, the top layer also gets deleted over there in that one. So if I delete some particular containers, and that is something which is gone, so it was suppose having like 3 layers, so the top layer will be simply deleted because the container is also deleted for that particular part. Now Docker uses a copy on write strategy with both Docker images and Docker containers. So whenever we perform any activity, or whenever copy on write strategies and strategy to share and copy files for better efficiency. So it's something which is being used to increase the overall performance of the Docker containers. It also makes Docker efficient by reducing the uses of disk space, because whenever required, okay, whenever is needed, only at that moment of time it's actually performing the copy, and it definitely reduces the overall disk utilization. And this is very important also, because when you have so many Docker containers up and running, so you have to worry, or you have to make the utilization of a disk, or your disk uses or resources also minimum. So that is also, you need to make sure that it does not exceed a particular value. So once the utilization is also less, then definitely the overall performance will also be better and improved over here in this case. So let's talk about some of the facts here. So the base layers are something which is purely read-only format, so you cannot do the modifications. Union file system saves the memory by avoiding the duplications of the files. The layers can be combined in a union file system to create a single image. So all these layers are combined and got a final product, or called a, you can call it as Docker image or Docker containers. And this allows a file system to appear as a writable, which is known as copy on write. So copy on write strategy is being used, so to do the changes, or to do the perform the modifications to this union file system while creating the different layers. So now let's talk about the Docker registry. Very important component, because even if you prepare the Docker image locally, and you don't have the collaborative tool, or you don't have the tool where you can share these images, definitely it's not easy for you to port these Docker images from one system to another. So Docker registry is very important for the portability feature of Docker. So Docker registry is a service to host and distribute Docker images among users. So it can be built up by one user, and multiple users can use it. For example, I'm using a Jenkins one. So Jenkins image is prepared only once, but it's being used by different people as such. Docker registry, again, it's a repository, is a collection of Docker images. So in a repository, you will be having like different Docker images as such. So in registry, a user can distinguish between the Docker images with their tag names. So for example, Jenkins is a kind of a single image. There might be different type of images there. Let's say that, okay, let's talk about Jenkins JDK8. So there will be an image called Jenkins. The name of the image will be same, but the tags will be different. So one tag could be like JDK8, one tag would be like JDK9, and one tag would be JDK10. So the difference between all these 3 Docker images is that JDK8 one is prepared on JDK8, it's running on JDK8, and if you want to use JDK9, in that case you have to pull down the Docker image of Jenkins with the JDK9 installed. So depending on the frameworks, or depending on the runtimes, so with these tags, different tags are processed, so you can have the distinguish between the Docker images, and whichever Docker image you feel you want to use, you can implement according to your requirement. And Docker by default is having its own cloud-based registry called as Docker Hub, which gets automatically connected when the moment you do the Docker installation. But in case you are working into your private infrastructure, so in that case you may use the repositories, Docker repositories on the specific JFrog Artifactory, or the private repositories also can be hosted. But Docker Hub is something which is having a public and private repositories both. So you can create either the public and private repositories. You can use push and pull activities to interact with these Docker images. If you want to download a Docker image, so you can run pull. If you want to push your Docker image to the Docker registry, in that case you can run the push activity. So in both the cases you are doing the interaction with the Docker Hub. So when you run some build process, or when you run the containers, there may be some Docker containers which is getting pulled down from the specific registry from the Docker Hub, and if that specific image and tag is available, definitely pull command will be successful. But in case of push command, you are pushing your custom Docker images. You cannot push the ready-made Docker images which is available. You can publish your own Docker image only to the Docker Hub, and then you can further on do the pull and push activity accordingly to those repositories. So whatever the ready-made and third-party images which is available, you can only do the pull activities to them. You cannot do the push activities. Push command scenario will only come when you are interacting with your custom Docker image. Next one is the Docker container. Now, Docker container is an executable package of an application and its dependencies together. So when we prepare a Docker container, we actually combine both the dependencies and the application source code inside it. So the Docker container don't have to look for the dependencies on the host machine on the server. So this is one of the benefit where we see that the portability is very easy, because whatever I'm building up on one system, everything is inside the Docker container, so I don't really need to do any further activity on other machines. So whatever works on one system can be easily worked on another system. So it's very lightweight also, so it can be easily deployed and executed on on their particular servers, because it does not take that much utilization like a virtual machine. So if you are looking forward for having your application hosted into your local system, you can easily do it within the Docker container. So the utilization is very less as compared to the virtual machine, so you don't have to worry about your host operating system and the configurations. So Docker containers can run in totally isolation, just like a virtual machine. So there is no interaction or there is no interference. So they share the OS called kernel, but the thing is they don't have the interface as such over there. So it works totally in isolation. Two different containers will not have any interaction unless and until we set up that the two containers to have the interactions. Now there is data volumes which can be shared and be used among the multiple containers. So you have the capability over here that if there is some unused space that can be easily shared across the multiple containers here. So it is built using the Docker images. So using the Docker images, the Docker containers are built up, and Docker run is a specific command which is used to build a Docker container. So if you got a Docker image, let's say that I have prepared a Docker image, a custom Docker image using the Docker file. Now if I need to create a Docker container out of a Docker image, I have to run a Docker run command. So Docker run command is nothing but it initializes or creates an instance of a Docker image. Now next component is the Docker Compose. Now typically when we work with the Docker containers, so we had to run, like if I want to run like 5-6 containers, I have to initialize like 5-6 times, or I have to run Docker run commands 5-6 times there. So and if you want to create a relationship between the containers, then definitely that is something which you need to manage using the Docker commands. But sometimes it's not an easy task for you to run those commands manually or remember those commands. So Docker Compose is a utility over here using which you can actually run multiple containers with a single service. You just got a kind of a single file, you just run it, and all the containers, definitions and relationships, everything is inside this Docker file here. So you want to run 2 containers, that's totally fine. Instead of running 2 commands, now you just have to run 1 file, and that will take care of that. Now you may be having more than 2 containers, 5, 6, 7, whatever number of containers you have, that can be easily deployed without any manual activity or without any maintenance onto the server. So these containers totally run in isolation, but yes, you can establish the interaction, that how they want to interact with each other, and that interaction you can put up in these Docker Compose file. So Docker Compose file is something which is written in a YAML format, and in this you define that okay, I need 2 containers, and this in this image should be there. These are the parameters which you need to run, and if you want to have the interaction or the linkage between the images, that also you can establish within this YAML files or within this Docker Compose file here. right? So let's say, for example, I want to have an application which requires Apache web server and MySQL database. Now I can create a Docker Compose file which can run both containers, and without, you don't require to restart or start them separately or initialize them separately. So I will be having a final Docker Compose file which is having like containers like Apache containers and MySQL containers both inside a single Docker Compose file here. So that's the benefit you're going to get, because now you don't have to run them separately, separate Apache and separate YAML MySQL. So you can get it done with the help of a single Docker Compose file here. Now, what exactly is the Docker Swarm? Now, Docker Swarm is a inbuilt, or it's a default orchestration tool which is being provided by the Docker itself. It's a service for containers which allows the IT administrators and the developers to create and manage a cluster of Swarm nodes. So in a typical world, when you do the installation of Docker, there is a limitation that some of the features like high availability, multiple instances, or scalability, all these things are not possible as it is with the core Docker. Now on top of that, you require the orchestration tools like Docker Swarm, where you have a swarm of node machines, 5-6 node machines are there, on which you can have your highly available application infrastructure implemented. Now this one means that if I want to run my applications 5 containers, 6 containers and 7 containers, for that purpose we are using the Docker Swarm. So each node of Docker Swarm is having a Docker daemon which is used for performing the interaction. So there will be a master node which is available, so it will be interacting with all the node machine on all the client machines, and this interaction will be in such a way that it will let them know, okay, I want to deploy the container or onto the node 3, so it will perform that activity and the container will be up and running on the node 3 there. So a swarm consists of two type of nodes. One is the manager node and one is the worker node. So manager is the master node which you can refer, and the worker node is the one which is actually doing most of the work. So the manager node is not something which is expected to host anything apart from the main component, but yes, you can always configure if you feel that you want to only deploy the container on the worker node. So that also you can do during the deployment of the containers. So manager will keep on connecting to the different worker nodes there, and whenever new request comes in, so it will basically try to connect and see that, okay, I just want to go ahead and deploy a container. So it will do the deployment of the container on the worker node. So the main work will be done by the worker nodes, and manager is just doing the management of all these resources. The worker nodes will be definitely receiving the request from the manager, and it will be proceeding and performing those activities. And if for some reason worker node is not active or online, so the master node will not be able to deploy the containers on that server. So right now, let's talk about a demo in which we have to create a Docker image using a Docker file on the Ubuntu 20. So we want to use a base operating system as an Ubuntu 20 there, and using that we are going to create a custom Docker image. So let's connect to our virtual machine and see that how we can do that. Okay, so as part of this demo here, we are going to prepare a Docker image, and in that we are going to use a base image of Ubuntu. So let's take an operating system of Ubuntu 20. 20 is the latest version of the Ubuntu operating system. So I have got a server, so let's see. So first of all, we have to install the docker.io package, which will install the Docker package, and then we can enable the service. We can make sure that the Docker service is up and running, because if the service itself is down, then we will not be able to perform any activity. And then a sample, if you run docker run hello-world, so that is going to pull a Docker image from the Docker hub, and a particular activity will be done to you. So once that is done, so we can say that, okay, the container is up and running and everything is got over there up and running. And then you can also try some of the Ubuntu Docker image also. If you feel that you want to try, you can do that. But the main demo which we need to do over here is that we need to prepare a custom Docker image, and in this one we will be having we will be using an Ubuntu base operating system. On top of that, we will be installing PHP, Nginx, all these different components. So we are going to have a PHP based website hosted onto the Apache web server as an Nginx, and then we will be able to access that application. So the very first thing which we need to do is that we need to create a folder. Let's say that I just create a particular folder called nginx-image, and then I create a Docker file over there. So Docker file content we are going to take from this one. So let's go to the server and see that how we can go ahead with the activity. Now what we can do is that we have got a server over here. Now in this server, what I'm going to do is that I'm going to proceed with the installation of Docker first. Now when I do the Docker installation first, so what will happen, that I will be able to have my Docker installation completed, and then further on I can take the further steps of having the accessibility of going through the understanding that what is this particular platform, or how to prepare different kind of containers. So I have got a particular container over here. So what I can really do is that I can simply say that, okay, I have got a server. So this is a Ubuntu server, so I'm going to run the command called app update first. Now this will do the update locally, so all the links and everything will be updated. Now the whole idea about doing the updates is that so that I will be able to have establish the fact that I'm trying to connect to the Ubuntu URL, so that at any moment of time I should be able to fetch on the latest packages. Now once that is done, so I'm going to run the command called apt install docker.io. Now the moment I do this, what will happen, that it will try to download some packages. It will ask for the confirmation. You can give your confirmation and I can say yes. The moment you give the confirmations, the download of the packages will proceed over here. Step by step it will download the packages and the installation will go on. Now once the installation is done, so what you can do is that you can see that Docker is deployed into your system or not. You can run Docker version command, or you can also use the service command to check, to make sure, to ensure that the Docker service is always up and running. If the service is not up and running, you have to make sure you have to enable it, you have to start that service. So these are some couple of steps which you need to do in order to make sure that your connectivity or your environment is ready with the Docker installation. And once the Docker installation is done, then only you will be able to proceed further with the further activities like preparing the containers, preparing the images and all that stuff. But if you don't have the Docker installed prior to that, then definitely it's going to be a problem. So just make sure that before even doing any kind of activity, before even doing any kind of steps, we ensure that the Docker is fully up and running. So it's going to take some time to download the packages, and we will wait for that, and once the installation is done, we will continue further on that part. Okay, now once the installation is done, so you can run the command called service docker status, and when you do that, it will let you know that whether the Docker service is available there or not. So you can start the service in case you don't get the proper response, and now you can see that it's showing up that a process is running. So earlier it was not up and running, it was inactive, but now it's active. And you can see here that dockride is the process which is running over here as a process to initialize the Docker daemon. So Docker daemon is up and running now, and we are good to go here. So now if we go and say like docker run hello-world, so we are doing a validation to our Docker instance, that whether our Docker instance is working fine as expected or not, because if there is any kind of problem with the Docker daemon and Docker daemon is not up and running properly, we would be able to get an error message over there. But right now there is no error message, which represents that yes, you are pretty much running the Docker image and it's giving you the proper response. So you will be able to see the Docker images when you run. So you will be able to see that the Docker image is pulled down to your system, and definitely you have executed that and it got you the response. Now the next thing which we need to do is that we need to run a particular Ubuntu one. So for example, if I go for docker run -it ubuntu bash. So what exactly we are doing in this one is that we are pulling down a Ubuntu Docker image and we are running the bash executable on top of that. The whole purpose of doing that activity is that so that if I want to do some process or I want to perform some activity, I should be able to connect to that Docker image. So the moment I do this, first of all, if this Docker image is available locally, that's great. It will immediately create the container. If the Docker image is not available locally, the very first thing which it will perform over here is to pull down the Docker image, the correct one. And as you can see here that it definitely pulls down a Docker image, and once it is done, so it got a terminal for you. Now you can see it shows that root at the ID, root at the rate 1 ID is there. This ID is nothing but it's a container ID which we are getting here. So definitely you are inside the Docker container, and when you run the Docker, when you run the exit command, you will see that you have come out of the Docker container over here. And the moment you run docker ps-a command, you can actually see also that how many container you deployed so far. So you ran hello world, you ran the Ubuntu one, both of them are stopped there. You can see the exit 0 in the status over here, because both of them are something which you ran in the interactive mode, so they are done. So if you want to keep your container up and running, you need to have a container which runs in the dash mode and always up and running. But for that, you have to go ahead to the level where we need to create a custom Docker image and do the setup accordingly. So let's see that how we can do that. Now I'm going to create a particular folder called nginx-image. You can pretty much give any name, whatever name you feel you want to perform, you can do that. Now in this one, I'm going to put up a file called Docker file. So let's see that what content we need to put as such when we talk about the Docker file, because whatever content you put over here, that is what according which the Docker image will be prepared. Now here we have to talk about, so first we have to see a base image. So we are saying that okay, Ubuntu 20.04 is what I want to use. Then we are giving some labels. Now these labels are used to give some information like what is the version, who is the maintainer, what is the description. You can do the customizations to this one. So these labels are actually defined and utilized so that I will be able to give an information that okay, so and so developer is something which we can contact. So if there is any kind of problem with the Docker file or with this build script, we have to reach out to that specific person. So this is what we typically do with the labels here. Now we also have to set up a parameter like Debian_frontend as in non-interactive, because whenever we talk about any build process in Docker file, it cannot be there in the interactive session. It should be there in the non-interactive. And definitely a typical scenarios like you can run app update command, and then we are installing the PHP, Nginx, supervisor, all these things we are doing. We are doing the installation. We are using the run attribute, run a particular step, and in there whatever the commands are executed, these statements will be executed when we will be doing the build process. And then we are using some environment variables. Okay, so nginx virtual host, php_conf, nginx_conf, and supervisor_conf. These are the different environment variables which we configuring over here. Now next thing which we have is that we have to transfer some files like probably nginx and the virtual host file. We may have to transfer from our Linux server to the destination to the Docker container. So for that we are going to run some copy commands, copy statements, so that we can do that stuff. And then definitely we are transferring the supervisor configuration file also to the server, so that we can have that configurations set up over there. And these supervisor_conf and all these different variables we have already established, where we are saying that what exactly configuration we are looking forward over here. And then we are creating some folder structure. Where www.html folder structure we are creating, so that we will be able to push some content over there. And then we have the volume configurations. So whatever the volume configurations are there, we are putting up, so that we will be able to have all the specific directories mounted on the host machine, on the host server, so that we can even talk about locally also. And then the star.sh is something which we need to run, because that's that will go into the command statement which needs to be executed. Because when you want to run your process, when you want to run your nginx process or your Docker container, some process should be up and running. That's where if any interactive process will run, then only the Docker container will be hold up. So that's what you can do or you can configure over there. So I'm going to copy this whole content. Now this whole content represents the complete Docker file. So we have already gone through this content one by one, but if we combine all these content together till the expose part, that's where we come up into this one. So expose, we are doing ATN443 over here, right? After this one, we have to create the host file, virtual host file, supervisor D file, and the star.sh file. So let's go back to the server here. Now in this one you have to you can use whatever editor you feel you want to use, you can do that. So this is what my master file will look like. You can see I'm running some run commands. These are the environment variables I'm using. Then further on, these variables I'm using just to define the paths. Okay, so you can see that this default file we are copying from the host machine, from the server to the Docker container, and then second file is supervisor d .conf file, and then we have start.sh file. So these are the different files which we want to configure here. So once this file is prepared, we have to type in, or we have to create a default file over here in this current directory. So in this current directory, we have to put up a file called default. Now in this one, we will be having the default virtual host configuration config. So we need to put a server attribute saying that we have to look forward for index.html or index.php and these kind of files from the var www.html directory there. So I'm just going to copy this content and put it up into this one. So this is how my final file look like. So I'll save it. And then we have a supervisor d.conf file.